Tonight, after a long and tiring day, you finally return to your familiar, gentle bed. You can set aside your work now. Set aside all the worries and clutter of life. Let your body rest. Rest completely. As you close your eyes for a moment and let everything around you slow down, imagine a vast night sky unfolding in front of you. There is no city noise here, no bright lights, only the deep, quiet curtain of the cosmos opening softly. Somewhere within that velvety darkness, the story of a very unusual child is beginning. This child isn't a person, and it isn't a character from a fairy tale. It is the very planet we all live on, Earth. Yes, our beloved Earth. Tonight, I'm bringing you a story about this planet. A story that will help you understand it more deeply, while also easing you gently into sleep. There is nothing I wish more for you than a peaceful night's rest, and the quiet joy of feeling a little more connected to the world around you. Now imagine that resting against your chest is a small blue sphere, glowing with a soft inner light. This sphere isn't a toy or a lifeless object. It is the early Earth, scaled down, small enough for you to cradle in your hands, yet big enough for you to feel its faint, slow heartbeat. With each delicate pulse, it whispers that inside this little world, a journey billions of years long is preparing to begin, full of upheaval, chaos, and quiet miracles. Before Earth became the familiar blue home we know, it was only a tiny part of the dust and gas drifting through the young universe. Scientists believe the material that formed Earth came from generations of ancient stars. Stars that lived, exploded, and fell apart long before our sun was born. When those aging stars died in supernova explosions, they scattered heavy elements into space: iron, oxygen, carbon, silicon. Those stardust fragments slowly settled into a spinning disk of gas and dust around a young sun, and after a very, very long time, they gathered into Earth. So when you imagine holding that little blue sphere, you're also holding a child made from the ashes of ancient stars. The journey we're about to take together isn't just a chain of dates and scientific numbers. It's a long story in which Earth appears as a character growing up within the solar system's family. From a tiny grain in the protoplanetary disk, Earth had to survive countless collisions, had to be heated, smashed, melted, reshaped, before it could finally become a round planet with a core, a mantle, and a solid crust. What scientists call giant impacts, late heavy bombardments, and orbital instabilities can be imagined as the wild, intense childhood stages of a young world growing up fast in a harsh environment. Along that journey, there were times when Earth was nothing but a blazing red sphere, a world so hot that its entire surface was an ocean of molten rock. There was a moment when a Mars-sized body named Theia hurtled toward young Earth and struck it with such force that a piece of Earth's own body was thrown into space and eventually gathered itself into the moon, our lifelong companion. There was a time when the sky above Earth was a stage of constant fireworks, meteors and comets crashing down, carving deep scars across the surface. At first glance, it sounds like catastrophe, but beneath the violence were quiet turning points, moments preparing the world for life. As you continue picturing that small blue sphere in your hands, try to feel the gentle paradox of the universe. The very blows that wounded Earth, the flames that engulfed it, the storms of rock falling from the sky. These became the conditions that allowed Earth to adapt and stabilize. Meteors and comets carried ice and organic molecules from the far edges of the solar system, and farther still. Each drop of water helped form the oceans. Each carbon molecule, Each amino acid may have laid the earliest building blocks of life. From a scientific view, these were simply transfers of matter. But through the lens of a story, they were gifts, cosmic presents sent to young Earth, even if they arrived wrapped in violent impacts. The story you're about to hear isn't just about how much hardship Earth endured. It's also about the remarkable conditions that came together to turn this planet into a peaceful home for life. Earth orbits at just the right distance from the Sun for liquid water to remain stable over immense spans of time. Its nearly circular orbit prevents extreme climate swings. The Moon stabilizes Earth's tilt, giving us regular seasons, the rhythmic backdrop life needs to evolve. The molten iron core generates a magnetic field that shields the planet from solar storms and cosmic rays. Slow-moving tectonic plates regulate climate through the carbon cycle. All these elements, placed side by side, resemble a delicate blueprint, one sculpted by time over billions of years. The echo of the previous chapter still lingers, drifting softly like a warm wave. The image of the small blue sphere resting in the listener's imagined hands seems to hum faintly, as if the newborn Earth were whispering its very first message. And from that gentle breath, the story glides deeper into time, slipping backward to moments when even the child Earth had not yet come to be. A time when everything began with Stardust. More than 4.5 billion years ago, the space surrounding our young sun was nothing like the elegant stage of well-shaped planets and smooth, stable orbits we see today. Back then, the sun had only just ignited after collapsing from the giant cloud of gas that birthed it. And around this infant star was not a clean, open void, but a vast protoplanetary disk, an enormous whirl of dust, gas, and particles so tiny they were nearly invisible. To the naked eye, it would have looked like a thin veil of mist surrounding the faint glow of the newborn sun. But hidden within that haze were the very first ingredients, the tiny grains that would one day write the story of Earth, of oceans, of air, of mountains, and eventually of life itself. Those dust grains drifted through the sun's warm orange halo. They had no fixed shape, no clear surface, just faint specks of light floating. Each grain was a shard left behind by generations of ancient stars that had exploded long ago. Inside them were elements forged in the glowing cores of those stars: iron, carbon, oxygen, silicates. These dust grains were like the first letters of a cosmic alphabet, slowly assembling into a grander narrative. And in that cradle of stardust, Earth had no form, no name, no future yet. But the ingredients that would make Earth were already there, waiting for gravity to gently bring them together. In that quiet space, gravity began its soft but tireless work. There were no sounds of collisions, no whispers of wind or water, only the silent movement of drifting grains edging toward one another. When two dust particles touched, a tiny force made them stick. Then another grain adhered, and another. The process repeated again and again, not hurried, not loud, but steady in a way nothing could stop. Before long, the tiny clusters grew into pebble-like grains, and then into larger fragments with shapes that slowly became clearer. If each dust grain were a single musical note, this gradual joining would be the opening symphony of the solar system, quietly taking form. As the listener imagines each tiny grain merging with another, a gentle sense of wonder might slip into the mind. No guiding hand arranged them, no will commanded them, yet everything happened exactly as it needed to. Dust gathered into pebbles not by chance, but because the laws of physics were doing their work, softly, powerfully, and without pause. This slow cohesion was the foundation for all the planets in the solar system, including Earth. At this stage, Earth existed only as a faint idea in the sea of dust, an almost fragile possibility waiting to be built upon. Picture the scene from afar. Sunlight from the young sun filters through thick dust, forming soft, slanted beams like morning mist. Tiny grains shimmer when the light touches them, a countless number of sparkles drifting in a pale golden ocean. It is as if the universe were holding an unformed child in its arms, warming it with the gentle glow of its central star. In this image, Earth is not yet a planet, only a dream being nurtured in a cradle of stardust. Time moved in the universe's own way, unhurried and unforced. Years, centuries, and millions of years passed like long, slow breaths. In each of those moments, dust continued to gather, forming clumps of material that grew bigger and heavier. Step by step, the child Earth was starting to take shape. It was still tiny, still delicate, but its existence was no longer just an idea. Beneath the thick dust, beneath the shimmering beams filtering through clouds of gas, a planet was beginning to collect the first grains of its body. The space around the young sun was far from peaceful. The protoplanetary disk was full of swirling regions where dust and gas clumped into denser bands. Hot winds from the young sun blew outward, weakened, then surged again, creating invisible ripples strong enough to shuffle matter unevenly. Yet within this gentle chaos, the gathering of dust became even richer. Some regions collected more material than others, allowing them to grow quickly, preparing to become the very first seedlings of future planets. If the listener tilts their imagination just a little, they might feel the softness in these images. There is no fire here, no explosions, no violent scenes. Everything unfolds in the deep quiet of space. Physics never stops working, yet it works in a way that makes no noise, no disruption. It is as though the universe were whispering, little by little, to create the worlds that would one day cradle life. In that cradle of stardust, Earth can be imagined as a developing embryo with no complete shape yet. Heavy elements were gathering into denser clumps. Silicate grains were beginning to bind, preparing to become a future crust. Lighter materials drifted in ways that would later form the planet's earliest atmosphere. Everything happened within an ancient stillness, a stillness that might make the listener feel as though they themselves are drifting into a light sleep. And now, as the dust grains begin forming the first pebbles, tiny but crucial building blocks of the future planet, the story is ready to enter a new phase. These pebbles will not stop at simply sticking together. They will continue to collide, merge, and grow through the persistent pull of gravity. From invisible dust to small stones, Earth's journey is taking slow but steady steps. And from this moment forward, the story will gently shift into the earliest stages of rock becoming a planet. The next chapter in Earth's transformation into a true presence in the vastness of space. From the stardust cradle where tiny particles first gathered into the earliest pebbles, the story flows onward like a quiet stream. Those little pebbles still spin gently within the dim halo of the protoplanetary disk, and from this point, Earth's journey of growing up is ready to enter a new phase. If earlier everything was fragile and scattered, like musical notes drifting, waiting to be arranged, then now the symphony begins to sound more clearly. The pebbles no longer simply drift. They begin to find one another, clumping into larger, heavier, more promising fragments. And from that moment, Earth truly begins the process of shaping its earliest body. Over time, countless grains of dust joined into pebbles, and those pebbles gradually became stones. Each stone carried within it the stories of millions of dust particles fused together, each particle holding the legacy of stars that had lived and died long before. The universe moved slowly but surely, assembling each bit of matter into the picture that was coming into focus. Small stones merged into clumps. Clumps collided and united, forming larger bodies called planetesimals. These were the very first seedlings of planets. Each planetesimal was like a foundational brick, and across millions of years, tens of thousands, hundreds of thousands of these bricks drifted toward one another, bound by gravity, merging into even greater masses. Within the vast cradle of the early solar system, Earth appeared like a faint embryo, still undefined, not yet bearing a clear form. But each time two planetesimals collided and fused, that young body grew a little bigger. Sometimes the impacts were so strong that fragments were hurled into space, flung away from the region where planets were forming. Yet most of the time, instead of losing material, the newborn Earth welcomed those pieces back as they drifted homeward again, as though the universe were trying to gather what had scattered, urging the future planet to grow full and round. Those falling fragments were like nourishment, like added pieces gently building Earth's early body. Though the process held moments of intensity, with flashes of energy from collisions and long plumes of dust exploding outward, everything still unfolded within the quiet embrace of space. There were no sounds, no sharp explosions, only silent impacts carrying enormous power, only shimmering dust spirals drifting in the glow of the young sun. As planetesimals grew larger, Earth was like a child just beginning to define its shape. Each collision fed it. Each merger was a step forward. Earth grew not in isolation, but within a network of cosmic debris constantly seeking connection. In this gentle, personified image, Earth resembles a small child sitting in the ancient playground of the solar system, quietly picking up stone toys scattered by the universe. The child isn't in a hurry, only patiently gathering piece after piece, stacking them, shaping itself. When a larger fragment arrived, the impact sent glittering debris flying like radiant dust. But after each burst, the pieces settled, returned, and gathered again. Seen this way, every collision stops feeling violent or frightening, and instead becomes the mischievous, sometimes clumsy steps of a child learning to grow. Sometimes too rough, sometimes too bold, but always moving toward a more complete form. Across those millions of years, collisions did more than simply pile matter into a bigger heap. Each impact carried energy that compressed, heated, and reorganized material inside the growing body. When planetesimals dozens or hundreds of kilometers wide collided, they didn't just join. They broke apart old structures to create new ones. From primordial dust to stones, from stones to larger blocks, the process gradually transformed loose material into a body with enough gravity to begin pulling itself into a round shape. This marked an important sign. The young Earth was entering the stage of true planetary formation. Alongside growing through collisions, Earth began developing its own internal character. Heavy materials like iron and nickel slowly sank into the centers of large planetesimals, preparing for the formation of a core. Lighter materials like silicates and oxides began forming outer layers. Even though Earth didn't yet have a stable surface, all this gathering and reorganizing of matter was the delicate groundwork for the crust, mantle, and internal structure we know today. The universe at that time was far from perfectly calm. Sometimes massive bodies drifted close, disturbing the dust around them. Sometimes chaotic motion sent many planetesimals flying from their paths, wandering into distant space. But this organized chaos was exactly what Earth needed to receive more material. Not every object could be kept, but the ones arriving at the right place, at the right moment, became part of the planet. It was as though young Earth were learning how to choose the right pieces to build its foundation. The image of that child gathering stone toys evokes a deep tenderness. In the vast, cold emptiness, one planet was patiently collecting tiny bits of matter, piece by piece, steady and unhurried. And that quiet persistence was the very thing that allowed something miraculous to emerge. Each small stone pulled in, each major collision that reshaped the interior, each plume of dust that led to new structures. All of it became a simple lesson in how great things often begin with the smallest fragments, accumulating gently over time. Gradually, the young Earth grew large enough to possess stronger gravity, strong enough to pull in even more material from its surroundings. This was the sign that the planet was shifting from an embryonic state to a stage of clear development. From a child who could only pick up the pieces that fell toward it, Earth was becoming a being with its own gravitational pull, capable of drawing in what it needed to continue growing. And once gravity took center stage, once fragments didn't just fall but were actively pulled inward by an increasingly commanding force, the planet's story entered a new chapter, a chapter of speed, of more intense collisions, of faster accumulation. This next chapter is the moment when Earth, the growing child, begins to accelerate in its journey of becoming, stepping into the era of giant impacts that would ultimately shape its destiny. From the first small stones gathered in the cradle of Stardust, the newborn Earth slowly formed like a delicate seedling, just beginning to find its shape. In the earlier stage, this future planet grew through the patient merging of planetesimals, the drifting seeds of planets floating inside the protoplanetary disk. But once Earth became large enough, heavy enough, strong enough for its own gravity to start making a difference, a new chapter opened softly. The story was no longer just dust turning into rock, and rock into clumps. It became an acceleration in the journey toward maturity, like the moment a toddler who once wobbled on unsure steps suddenly learns to run, suddenly reaches out to everything around it in order to keep growing. When the embryonic Earth reached a certain size, its gravitational pull grew more powerful. Instead of receiving only accidental impacts, it began actively drawing toward itself the pieces of rock drifting nearby. Other planetesimals, each also struggling to find a place in the chaotic cradle of the newborn solar system, were pulled in more frequently. They fell, collided, melted, and merged into Earth's expanding body. Earth's gravity became like an invisible hand, gathering material from all around, making the growing planet thicker, heavier, and fuller with each passing day. This was no longer the slow accumulation of dust. It was a leap in growth, where every encounter with another rocky mass left a clear imprint. And so, in the silent expanse of space, the early Earth grew rapidly in its own way. Collisions with planetesimals were not simple hits. They released enormous energy, turning into heat, melting the already scorching young surface. Large fragments striking Earth sent sprays of molten rock outward, flashes of light flickering in the darkness of the infant universe. Yet instead of being weakened, Earth gained mass with every encounter. Some debris was flung outward, but most of it came back, pulled inward by the now stronger gravitational field, becoming part of the planet's body. Every impact was nourishment. Every blow made Earth larger. And with time, This embryonic body became harder and harder to distinguish from a true planet. In this moment, Earth appears like a mischievous child in the cosmic playground. It was no longer the little one sitting still, picking up pebbles. It had begun running around, bumping into other playmates. Each collision sparked a burst of heat, but instead of fear or injury, the child only grew stronger, larger, more confident. As if with every stumble, Earth learned something new, gained a new part of itself. Other planetesimals, though also trying to grow, were not all lucky enough to be in the right place. Some were pulled into Earth and became part of it. Others were knocked away and drifted into the outer darkness of the solar system. Still others merged with each other, only to eventually be captured by Earth's growing pull. In this humanized image, the universe resembles a patient mother, doing nothing directly, simply watching as her young Earth keeps bumping into everything, loud, energetic, clumsy, but full of determination. The tumbles are unavoidable, but they are exactly what teach the child how to stand firm in the vastness of space. Each strong collision stirred clouds of gas and dust around the planet, as if Earth trembled and then regained its balance to grow even more. The cosmic mother did not correct or intervene. She simply let time and the laws of physics teach her child to grow in the most natural way. As the planetesimals grew larger, Earth entered a phase of rapid development. Over millions of years, it became big enough not only to possess strong gravity, but also to retain internal heat. Heat from collisions, heat from the radioactive decay of elements inside the planet, and heat from the compression of material. All of it transformed the entire Earth into a glowing, fiery sphere, boiling from within. The surface was constantly churned by molten rock. New impacts prevented it from ever cooling completely. This was a time when Earth was physically chaotic, but evolutionarily orderly. Everything was moving in the right direction, at the right pace, in the rhythm nature had set for a planet destined one day to host life. And as this embryonic planet continued to grow, something else important happened. Its gravity began affecting the orbits of other bodies. Small objects that once drifted past without concern now fell into Earth's sphere of influence. This caused Earth's growth to accelerate exponentially. Each time it grew, it pulled harder. Each time it pulled harder, it grew even faster. This feedback loop continued for what seemed like eternity, but in the eyes of the universe, it was nothing more than a brief moment of childhood. Earth was no longer the child who simply gathered scattered bits. It had become a powerful presence in the early solar system. It was growing increasingly clear that this planet would not remain some aimless drifting rock. It was truly becoming a world, a real planet. And while its surface still glowed with fire, while the flashes of new impacts still flickered, while dusty clouds still drifted around its orbit, the story gently shifts to the next chapter. The chapter of oceans of fire, of layered materials. The chapter in which Earth first begins to form a core and a crust, stepping into the radiant, molten years of its early childhood. From the relentless collisions of the earlier stage, the infant Earth grew quickly, like a mischievous child stumbling again and again into its rocky friends, each impact making its body rounder and fuller. But this growth didn't just bring size and mass. It also trapped an enormous amount of heat beneath its ever-thickening layers of material. As the young planet kept pulling countless small and large bodies toward itself, each impact releasing another burst of energy as heat, a quiet turning point began to take shape. That steady, unavoidable accumulation guided Earth into an entirely new chapter, a chapter of fire, of melting, of deep transformations that would shape the internal structure that would one day cradle life. And from the edge of that noisy, chaotic era of impacts, Earth gently shifted into its fiery childhood. When the rising heat surpassed the limit that solid matter could endure, the entire body of the young Earth began to melt. It was no longer a pile of unformed rocks, but a blazing sphere, like a colossal fireball suspended in the dimness of the early universe. The temperatures were so high that everything, from the surface down to the deepest regions, softened like molten metal in a forge. Except this forge was the size of a planet. If Earth were a child, this would be the stage where it resembled a newborn flushed with a fierce fever, its tiny body burning hot, nothing about it yet stable. Within that ocean of fire, the elements began to move in ways that would define the planet's destiny. Iron and nickel, the heavier elements, slowly sank downward, pulled toward the center where gravity was strongest. They gathered and compressed, forming the Earth's core. This core would become not only the densest region, but also the most essential, for it would later generate the magnetic field that shields the planet from cosmic storms. Meanwhile, the lighter elements, silicon, oxygen, and silicate compounds, rose toward the top, spreading out near the surface. They cooled slowly, solidifying into a thin, fragile, and unstable primitive crust. This process, known as differentiation, was like the moment Earth first formed its own heart and skin. Within the glowing magma ocean, the planet was quietly organizing its body, assigning each element to the place it would occupy for billions of years to come. At the surface, the scene was nothing like the gentle Earth we know today. No blue oceans, no white clouds, no brown continents. Only vast, endless seas of magma churning and boiling, swirling like fiery oceans that never rested. Enormous magma plumes shot upward from the depths, erupting into bursts of orange-red light that pierced through the thick dust surrounding the newborn world. These eruptions came one after another, like the long, wordless cry of a child just entering life amid chaos. From deep within, toxic gases, water vapor, carbon dioxide, sulfur dioxide, escaped and blended into a heavy, dark, suffocating atmosphere. This air wrapped around the planet like a hot, choking mist, making the surface glow in shades of molten orange. Yet inside that fierce and overwhelming picture, the planet's formation unfolded in a way that felt natural, almost gentle, following the quiet laws of nature. Even though the magma oceans were violent, on a cosmic scale, this was simply a necessary stage of transformation. Each layer of material moving into its rightful place was like droplets of color settling into the correct corner of a slowly forming painting. Though the surface trembled with heat, though the air was thick with gas and dust, the transformation carried a strange sense of order, as if everything was happening with a rhythm the universe had memorized long ago. If we imagine Earth in this era as a living being, it would be like a baby enduring its very first fever. Its body was so hot that all its skin had turned into flowing liquid, nothing yet strong or solid. Its cry was soundless, only the deep roar of constant eruptions rising from within. And this fever didn't last hours or days, but millions of years, long enough for the planet to rearrange every element, long enough for its iron-nickel heart to take full shape. The fever burned fiercely, but it was necessary for a planet's body to grow. During this time, the first strokes of Earth's atmosphere were being painted. Although filled with toxic gases and impossible to breathe, its heaviness helped trap heat, preventing the magma oceans from cooling too quickly. This period was like a heavy, essential blanket wrapped over the infant Earth, keeping it molten long enough for its internal structure to form. Had the planet been smaller or unable to retain heat, differentiation might never have fully occurred, and Earth would not have developed the strong core or protective magnetic field it has today. But everything unfolded with nature's delicate, improbable perfection. Across the chaotic surface, towering volcanoes hurled glowing material into a sky thick with gas. The winds weren't like today's breezes. They were movements of scorching gases pushed upward by the boiling magma. The sky was not blue, but a swirling blend of orange, deep brown, and smoky black. Earth at that time looked like a glowing sphere adrift in darkness, intense yet strangely steady, chaotic yet somehow ordered. Despite the dramatic scenery, there was a quiet sense of reassurance in knowing that everything was progressing exactly as it needed to. The fever would not last forever. As heat gradually dispersed throughout the planet's body, as the core finished forming and the primitive crust began to cool bit by bit, nature was preparing the next transition. From a burning newborn crying in fire, Earth would slowly cool. One day, the magma oceans would solidify, rocky surfaces would emerge, and the planet would enter a calmer era, an era where liquid water could appear, and the atmosphere could begin to change. And from this great fever, the story will gently shift to Earth's next stage, when it forms both its crust and its core completely. The moment the planet begins to take shape as a true home, with a stable structure ready to welcome the wonders yet to come. From within the blazing fever that lasted for millions of years, Earth slowly emerged from the most intense, molten stage of its childhood. The magma ocean still churned, volcanoes still hurled red-orange pillars of light through a sky thick with smoke. Yet amid all this chaos, a quiet but profound change began to unfold. The planet's temperature, though still scorching, was starting to distribute more evenly. Deep within Earth's interior, after being stirred by countless collisions, materials were beginning to rearrange themselves under the firm but gentle laws of nature. And from that moment, the story of the young planet shifted softly into a new chapter. A chapter of structure, of foundations, of laying the very first stones that would one day allow Earth to become a true home. As the fever eased, Earth's surface began to cool little by little. The process was not quick, but slow and certain, just enough for the first solid outer layer to form. From the roiling surface, patches of magma cooled and crystallized into a thin sheet of rock. This crust was fragile, easily shattered by large eruptions, but it was the planet's first skin. Beneath that thin shell, the mantle remained molten, moving quietly like deep, unseen currents rearranging their own order. Deeper still, in the very center of Earth, where pressures were beyond imagination, molten iron began to crystallize. Pulled inward by gravity, the iron atoms were squeezed so tightly that they could no longer move freely. Forced together, they froze into an incredibly dense solid mass. This became the inner core, the first metallic heart of the planet. Surrounding it was the outer core, still liquid, still in restless motion. The contrast between the solid inner core and the flowing outer core created a powerful system of energy that would eventually generate Earth's magnetic field, an invisible shield protecting future life from cosmic radiation. Encasing the core, the mantle continued its slow dance. Hot, lighter material rose upward, while cooler, heavier material sank, creating convection cycles that would last for millions of years. This mantle was like Earth's silent musculature, always shifting, never still. And above it all, the crust gradually thickened with time. As it cooled and stabilized, Earth gained its first true solid surface. All of these layers, the inner core, outer core, mantle, crust, formed the walls, roof, and foundation of a house. It wasn't peaceful or cool yet, but the framework was there, ready for the chapters that would follow. Even as Earth's internal structure took shape, its surface remained the most active place of all. Volcanoes erupted constantly, acting like open gateways from the planet's depths, releasing trapped heat and gases. Each burst of fire flung vast amounts of CO2, water vapor, nitrogen, and other gases into the air. Though unbreathable, these gases blended together to form the planet's first atmosphere. Looking up at Earth's sky, then one would see no blue, only a heavy veil of steam, dust, CO2, and sulfur gases. Dense and thick as it was, this early atmosphere played a crucial role. It trapped heat, keeping the planet from cooling too quickly and allowing its interior structure to finish forming. Earth during this time resembled a living being just recovering from a great fever, wrapped in a blanket of steam and toxic gases to keep its still delicate body warm. That blanket was neither beautiful nor clear, but it was essential. It helped Earth balance between releasing heat to space and holding on to the warmth needed to continue its internal processes. This early atmosphere was also the groundwork for what would come later. Water vapor would condense into rain once the planet cooled enough. CO2 would join geochemical cycles that would shape future habitats, and nitrogen would become the main ingredient of the air we breathe today. Although Earth was still far too hot for life to appear, all the necessary ingredients were slowly gathering, like puzzle pieces preparing to complete a grand picture. The iron core, the metallic heart, would power the magnetic field that would one day shield living things from solar wind and cosmic particles. The solid crust, still thin, would become the bedrock beneath the first oceans and later the earliest continents. The primordial atmosphere would not only cushion the surface from smaller incoming space debris, but also keep the planet warm during a time when the sun was much weaker than it is now. And so, even though the surface was still erupting endlessly, even though the sky remained full of hot dust and toxic gases, Earth was genuinely beginning to take the shape of a home. A home not yet finished, messy, noisy, and restless, but one with its foundation, frame, walls, and roof in place. Each layer within the planet was a quiet preparation for the future. And as the final pieces of this internal framework settled into place, the chaos began to subside. The eruptions continued, but with less fury. The surface cooled bit by bit. The thick atmosphere stabilized. New rock layers slowly formed into larger patches. All of this may seem like simple steps in the long story of a planet. Yet within this soft, steady transformation, the most extraordinary possibility was drawing nearer. Life. Earth was preparing a vast, sturdy, protected cradle. And as its crust cooled just a little more, as water vapor gathered enough to form the first rains, the story would soon step into the next chapter. A chapter of colossal changes, of impacts from distant space. A chapter where the final pieces needed to create oceans and the first seeds of life would be delivered to Earth. When Earth's first crust began to cool, when its iron core had crystallized into a metallic heart at the planet's center, and when the early atmosphere wrapped around it like a thick, warm blanket, the young world seemed to have finally passed the most chaotic stage of its childhood. Beneath its fragile crust, the mantle still churned. On the surface, volcanoes still sent waves of heat and ash into the air. Yet overall, Earth was drifting toward a state of relative stability, stable enough to keep evolving, stable enough to lay the groundwork for the distant future of life. But just when nature seemed to settle after so many upheavals, the universe prepared a turning point for Earth, one far more dramatic than anything it had ever experienced. A disaster that destroyed and yet created, a blow of unimaginable force that also delivered the greatest gift nature would ever give this planet. And at that delicate boundary between stability and chaos, the story shifts to its next chapter, the chapter of the fateful collision. Around 30 million years after Earth first formed, in a region of space where young planets were still jostling for stable orbits, a massive body named Theia appeared. Theia was roughly the size of Mars, not a stray meteor, but a true protoplanet searching for its place in the newborn solar system. In that turbulent space, unfinished orbits sometimes led to unavoidable encounters, and Theia, in its quiet journey, began inching closer to Earth, as though pulled by an invisible gravitational thread. A thread that bound the two worlds to a shared future they could not escape. Then the moment came. Theia struck Earth with a force beyond anything words could compare to. This was not like the earlier collisions with planetesimals that left craters or briefly heated the surface. This was a planet-scale cataclysm. When Theia hit, a portion of Earth's crust and mantle was blasted into space, streaming outward like bright ribbons of molten material thrown from the planet's skin. The entire world shook to its core. The heat unleashed by the collision turned Earth's already scorching surface into an even fiercer blaze, glowing a deeper, more violent orange than the magma oceans that had existed before. And yet the strangest truth is this: in that destruction, nothing ended. Something began. The debris hurled outward did not disappear into the void. Instead, it gathered around Earth, forming a vast ring of glowing rock and dust. Each fragment carried a piece of Earth, a piece of Theia, and a fragment of cosmic history older than either world. In just weeks or months, a blink in cosmic time, these fragments began to swirl together, clumping and growing into a round, stable body. Out of fire and chaos, a new world was born: the Moon. If Earth were a living being, the impact with Theia would be the defining moment that changed its body forever. From this collision, one that seemed to bring only pain and loss, Earth gained a companion. A part of its own body had become a satellite, but not one that drifted away. The Moon began circling Earth like a child or twin separated from the same flesh. The mixed fragments, half Earth, half Theia, formed a celestial object with a shared origin that would bind it to Earth for all time. In human terms, the collision was like a wound too immense to imagine. A portion of Earth's body was torn away, its crust stripped, its surface deeply scarred. Yet from that injury came a gift: the Moon, born within Earth's gravitational embrace, orbiting faithfully around it. Though Earth had endured an unavoidable trauma, it was no longer alone. It now had a companion, one that would shape its destiny and the destiny of every living creature that would appear billions of years later. This image is not only poetic, it is scientifically accurate. The Moon truly formed from Earth's own material, so in a very real sense, it is a piece of Earth that broke free. From that moment on, the Earth-Moon pair became a uniquely connected system, a young planet with a powerful iron core and a surprisingly large moon born from its own body. Not every planet has a moon formed this way. Because of its origin, the relationship between Earth and the Moon carries a kind of cosmic inevitability. a bond written by collision. As the ring of dust and rock condensed into the moon, the chaos gradually calmed. When the moon settled into its orbit, it began influencing Earth in return. Even as Earth was still recovering from the collision, the moon began acting as its guardian. It stabilized Earth's tilt, preventing the young planet from wobbling wildly in space. It stirred the first tidal motions in the magma oceans, and later, in the oceans of water that would eventually form. Over time, the moon became a gentle lantern in the night sky, shining softly upon Earth from its earliest days all the way to the present. Looking back, it's hard to believe that a catastrophe could lead to such wonder. But many of the universe's greatest events carry this paradox: creation born from destruction. Earth lost part of itself, but in return gained a lifelong companion whose influence would be profound. All planets endure collisions, but not every collision leaves behind a moon so beautiful, so stabilizing, and so intimately connected. From here, Earth's story will drift into a new chapter, an era in which the moon begins shaping climate, axial tilt, tides, and the long-term stability needed for life to emerge. After the fateful collision, the planet had a new, gentle light to accompany it on the long journey ahead. And as the moon began its first orbits around the young Earth, the planet seemed ready for the next dramatic steps in its fiery early history. After the fateful collision between Earth and Theia, while the cloud of rock and dust still swirled in a soft, hazy ring around the young planet, an uncanny silence settled over space. The fragments hurled upward in that explosive moment slowly began to gather, shifting from chaos into order, from debris into form. And in a span of time so brief it almost defies belief, the moon was born. A new celestial body, shaped from the very wound of its parent planet. As the final ring of dust condensed into a satellite, Earth no longer spun alone in the dark. A companion had arrived, not by chance, but as if woven directly into Earth's destiny. From that moment on, the story moved into its next chapter, the chapter of the deep, lifelong friendship between the blue planet and its newborn companion. In its earliest days, the moon did not hover far away as we see it now. When it first crystallized, it orbited extraordinarily close to Earth, so close that it dominated the night sky, hanging as a vast, glowing disk many times larger than its current size. Imagine the deep red sky of the Hadean era, the atmosphere thick with dust and steam, and within that hot, heavy haze, a young moon glimmering like a warm lantern, soft but powerful, wrapped around Earth like an embrace after the violence of the Great Impact. Its light would not yet have been silver-white but tinted orange and red, reflected from its still warm, newborn surface. Whatever its color, it carried a soothing message, a presence that was steady, patient, and profoundly calming. The moon was never just an object orbiting Earth. From the very beginning, it became essential to the planet's fate. One of its greatest roles was stabilizing Earth's axial tilt. Every planet spins around its own axis, but not all of them keep a steady angle for billions of years. Mars, for example, lacking a large moon to anchor it, wobbles wildly over time, causing abrupt, intense changes in climate that may have stripped away its atmosphere and water. Without the moon, Earth might have suffered the same fate, tipped and tossed by the gravitational pull of other planets, its tilt constantly shifting, creating climate chaos too severe to allow stable life. But the moon arrived in time. From the moment it formed from the swirling ring of debris, it acted like a gentle guide, holding Earth's tilt close to 23.5 degrees for billions of years. That tilt creates the seasons, spring, summer, fall, winter, and because of it, Earth's climate shifts just enough to promote diversity, yet not so violently that the planet becomes uninhabitable. This is a delicate, perfect balance, and the moon is the thread that keeps that balance from unraveling. Its influence went even further. The moon created the tides, the rise and fall of the oceans that today seem so ordinary, but in Earth's earliest days may have been the planet's very first rhythm. When Earth was young, liquid water had not yet appeared in abundance. But later, when rain began to fall and oceans formed, the moon's pull generated the first tidal movements. The tides rose and fell like a slow heartbeat, churning the early seas, helping organic molecules collide, combine, and evolve across countless cycles. Some scientists believe these gentle, repeating pulses may have created the chemical environment needed for the first life to emerge. The tides were like the universe's lullaby, a long, steady rocking that allowed fragile sparks of life to meet in the primordial ocean. From a human perspective, the moon feels like a devoted friend, close enough to influence Earth, distant enough not to intrude. It never leaves. Though it orbits Earth for billions of years, it doesn't drift away entirely. It only inches outward at a pace too slow to notice, just a few centimeters a year. But even as it retreats a little, the moon keeps its soft gaze fixed on the planet that birthed it. And from those earliest days to now, the relationship between Earth and the moon has been one of the most enduring in cosmic history. Earth spins, the moon spins, and together they journey around the sun. Oceans recede, mountains rise, continents split and rejoin. Yet the moon continues its quiet devotion, steadying Earth's tilt, shaping the tides, lighting the night, and staying near through every transformation. Some might think the moon is just a random satellite, but when the entire story is seen clearly, it becomes almost impossible to believe it was mere coincidence. Without it, Earth would not be as stable as it is. Without it, the climate would not be gentle enough to nurture life. Without it, the tides would be far weaker, and the early chemistry of life might have unfolded very differently. From this perspective, the moon is not simply a gift born from impact. It is a saving grace, the reason Earth became a world capable of cradling life. And as the moon's glow softened over time, as its surface cooled and took on its quiet gray tone, Earth began preparing for another trial from the cosmos. The moon stayed beside it, watching as Earth braced for the coming storm of meteors, a violent bombardment that would shape the surface of the young planet and bring water and ingredients essential for life. And thanks to the moon's silent guardianship, the story will soon drift into its next chapter. The era of cosmic rainstorms, where Earth continued to grow through another round of fierce, transformative trials. Beside the young Earth, the newborn moon continued its quiet first orbits around its parent planet. Its gentle light softened the sky, still hot, still red, still thick with ash from the Hadean age. After the fateful collision, Earth had gained a loyal companion, one that steadied its axial tilt, helped form the first tidal rhythms, and guided the planet out of chaos with a calm, persistent presence. Yet even with that precious stability, Earth's peace would not last long. The universe, following its own rhythm, was preparing a far greater trial for the young planet, one more intense than anything it had endured before. And from here, the story moves into a new era, an era of ferocious meteor storms, where Earth's surface would again be reshaped in fire and rock as part of the unavoidable process of growing up. Between about 4.1 and 3.8 billion years ago, The solar system entered a period scientists now call the Late Heavy Bombardment. It was not a single event, but a span of hundreds of millions of years during which meteorites, asteroids, and comets from distant regions of the system plunged into the inner planets in unprecedented numbers. The orbits back then were still unsettled. Large bodies were perturbed by the gravitational forces of Jupiter and Saturn, sending countless smaller objects hurtling toward Earth and the other rocky planets. In the darkness of the early cosmos, thousands of streaks of light slashed across the sky each day, each one a fragment of space rock racing toward the young Earth at unimaginable speed. When these meteorites struck the still hot and unstable surface, they carved enormous craters. Some impacts were so deep they pierced through the nascent crust, releasing new torrents of magma. Others were so powerful that shock waves rippled across the entire planet. Viewed from space, Earth would have looked like it was trapped in a storm without end. Bursts of light erupting constantly, plumes of dust rising from the surface, and sheets of fiery debris drifting through the thick atmosphere. The already hot, heavy atmosphere grew even denser as vast amounts of dust and gases were blown upward by the impacts. Sunlight had to force its way through this deep orange haze before reaching the ground, giving the world a dim, copper-red glow, like an endless sunset. Earth in this era resembled an adolescent in the throes of a turbulent growth spurt. Volatile, unstable, tested again and again, each new impact leaving another scar on its surface. At times, if liquid oceans had begun forming, they may have been partly vaporized when large meteorites struck, turning the sea's surface into clouds of scorching steam. Newly cooled crust melted once more. Volcanoes were triggered again and again, releasing CO2, sulfur, and water vapor back into the sky. The entire planet felt as though it was returning to its earlier fiery childhood, even though its internal structure had already begun to stabilize. Yet beneath all this destruction lay a quiet generosity from the universe. Each meteor, each comet, brought not only stone, but ice and organic molecules, materials essential for life. These violent storms were not merely assaults, but seedings. The water within comets melted and blended with the vapor in the atmosphere, eventually pooling in low basins once the surface cooled. Organic molecules, amino acids, carbon compounds, were scattered across the land, the rock, and the slowly cooling magma seas. On a human level, perhaps the most remarkable thing was not what fell from the sky, but Earth's resilience. This young planet, despite being struck repeatedly, did not break. Even when the crust was torn, melted, and remade, Earth held its shape. Even when impacts rattled the planet to its core, its deep structure remained intact. Like a teenager thrust into life's hardest trials, Earth pushed through each storm, each wave of upheaval, and with each test, it grew more stable, more solid, more ready for what would come. The moon, its newfound companion, remained there through it all, circling Earth as a silent witness to every upheaval. Moonlight still touched the dusty veil of the atmosphere, even if often dimmed or obscured. And though the moon could not stop large meteorites from falling, its steadying influence kept Earth's axis from lurching wildly with each impact, preventing the planet from tumbling into unpredictable chaos. Gradually, the bombardment eased, not because all meteors vanished, but because the solar system itself became more orderly. The giant planets, Jupiter and Saturn, swept up or flung out most of the leftover debris, clearing the inner orbits. Stray asteroids were either absorbed by other planets or hurled into the dark beyond. As their numbers dwindled, the night skies over Earth grew quieter, with fewer streaks of falling light. The planet's surface remained scarred, but the most violent period had passed. Magma fields cooled into rock. The heavy water vapor in the thick atmosphere waited for the right moment to condense into the first long-lasting rains. Rains that would fall for millions of years. And in that gradual calming, Earth stepped softly into a new chapter. The chapter of water, of oceans, and of the first stable environments where life could begin. Having endured the greatest trials of its youth, Earth, the child of the universe, had proven its resilience. And from here, the story gently turns toward the next stage. When the gifts of water and organic molecules from space begin transforming the once scorching surface into deep blue oceans, the very first cradle of life. As the cosmic bombardment of the late heavy bombardment slowly faded, Earth seemed to step out of a storm that had lasted hundreds of millions of years. The scorched scars, the vast impact basins, and the lingering haze of dust were still there. And yet, beneath all that wreckage, something quietly strange was beginning to take shape. In what looked like pure devastation, the first faint seeds of an entirely different future were stirring. And right at that meeting point between chaos and calm, the story turns to a new chapter. One filled with unexpected gifts from distant skies. Looking back on what the planet had just endured, it is hard to believe that those firestorming meteorites could play any positive role at all. But the universe often works in ways that feel paradoxical, yet perfectly balanced. Those icy wanderers, traveling for millions of years through remote orbits, carried with them something essential for life: water. Not just a few scattered droplets, but enough to help form the vast oceans that today glow a deep blue when seen from space. In a gentle imagining, each of those icy meteorites feels like a wrapped gift hurtling silently out of the cosmic dark. When they struck Earth, their ice melted instantly in the red-hot blast of impact, releasing water into the atmosphere. The vapor condensed into rain, falling onto the still steaming surface and filling the deepest basins. Drop by drop, water from beyond the stars gathered into the oceans that would cradle the Earth. Each drop felt like a quiet whisper, easing the young planet after its long, trembling trials. But water was not the only gift. Inside carbon-rich meteorites were organic molecules, amino acids, carbon compounds, the very building blocks of life. Though still debated in science, the idea that meteorites delivered the seeds of life remains one of the most poetic and intriguing hypotheses we have. Perhaps every meteorite that fell was a soft knock on Earth's door, a small cosmic offering that sprinkled the primordial oceans with the molecules needed for life to take root. The image carries a curious tenderness, as if the entire universe had worked together to nurture this blue world, giving it the raw materials needed to begin writing the story of living things. Earth did not simply receive water and organics, it received a chance to become a place where life could truly begin. Stranger still was how perfectly measured those gifts were. Had Earth received too much water, it would have turned into a pure ocean planet, a sphere of endless deep seas, with no land, no rocky crust cycling minerals, no chemistry between water and stone. Under those enormous pressures, thick layers of ice would have formed at the bottom, separating the ocean from the rock below, blocking the reactions essential for life. A water-rich world might be beautiful, but perhaps never a home for complex living beings. And if Earth had received too little, it would have remained nothing more than a barren, dusty desert of stone. But our planet was given just the right amount. enough to create wide, deep oceans without drowning every continent, enough to establish the water cycle and the carbon cycle, enough to nourish life, yet still leave room for land to emerge later. It was like a cosmic equation balanced with exquisite care. Nothing extra, nothing missing. In a soft, whimsical vision, each shooting star becomes a kind of cosmic Santa's gift, carrying water and tiny organic molecules inside. No jingling bells, no bright ribbons, just a quiet flash of light as a meteorite touched the young Earth. And yet the value hidden in those silent gifts was immense enough to change the entire history of the planet. Thanks to those quiet gifts from the heavens, Earth's cradle for life was fully prepared. And so, from the ashes of ancient impacts, from the roar of the bombardment, and from icy stones that seemed meant only for destruction, something gentle began to rise. Water gathering in lowlands, oceans slowly spreading blue, and within those waters, organic molecules meeting for the first time. Earth shifted from a world of fire to a world of water, from a realm of storms to a realm with the chance for life. This transformation unfolded slowly, over millions of years, but it moved with the softness of a long exhale after a great upheaval. It was as if Earth had entered a time of soothing, bathed in the very waters delivered by meteorites that once shook it. And this warm, gentle environment would become the foundation for the next part of the story. When the oceans filled the surface, the atmosphere grew more stable, and life finally found a place to begin. From the chaotic rain of cosmic stones before, the story flows naturally into this chapter. When the violence subsides, the gifts of the universe come into view, and as Earth quietly embraces those falling gifts, the journey toward life crosses into a new threshold, soft, silent, and full of promise. After the final meteor storms of the bombardment era faded away, after the sky no longer glowed with fiery streaks falling from space, Earth seemed to be given a chance to take a long, deep breath. Countless fragments had rained down upon the young planet, delivering ice and organic molecules like quiet gifts from a distant universe. Out of that chaos, the first oceans began to form, and Earth's surface started shifting from a glowing world of fire into one slowly draped in soft, cooling blue. It was in that moment that the planet stepped into a new chapter, a chapter of cooling, of endless rains, and of the very first appearance of the blue Earth in its long history. The years following the late heavy bombardment marked a time of profound transformation. The immense heat left behind by countless impacts was slowly radiated into space, while the dust and gases in the atmosphere began to settle, allowing the faint light of the young sun to seep through. The crust, once so thin and fragile it could melt with every strike, now grew thicker and far more stable. Though pockets of magma still glowed beneath the surface, most of the planet had finally cooled enough to remain solid. For the first time, Earth possessed a truly stable crust, a vital foundation for every geological and biological process that would come afterward. As the surface cooled, the thick, moisture-laden atmosphere began to release its water. Vast clouds formed and wrapped around the sky. Then the rains began. Not brief showers, but storms that lasted for millions of years. Rain fell onto the still hot red surface and evaporated almost instantly, rising once more to the sky, where it condensed again, creating a continuous cycle. But as the planet cooled further, the vapor no longer escaped as quickly as before, and the raindrops were finally able to rest on the surface. They collected in low basins, forming the first pools of water. Over time, those pools merged into sprawling primordial oceans, a deep blue blanket that gently wrapped itself around the young Earth. Seen from space, Earth might have looked very different from what we know today. The oceans were not the clear blue we now recognize, but a darker, almost black shade, heavy with minerals and dissolved materials from the newly formed crust. Scattered among those vast waters were small patches of land, perhaps the earliest cratons, the first fragments of continental crust. They were rough and barren, without soil, without plants, without any hint of green life. Yet their presence created the first contrast between sea and land in the planet's history. Beneath the surface of those primordial oceans, an entirely new world was quietly at work. There, complex chemical reactions unfolded between water, minerals, and the organic molecules delivered from space. These reactions, subtle and silent, formed the foundation from which life would later emerge. Heat from hydrothermal vents on the ocean floor powered crucial chemical processes, while the gentle tides, pulled by the moon, stirred the waters, allowing molecules to disperse, collide, and bond. Every factor seemed to be waiting for the right moment to spark a miraculous turning point in natural history. Earth's atmosphere at this time was thick, but still very different from the air modern life needs. Carbon dioxide, water vapor, and methane dominated the skies, creating a strong greenhouse effect that kept the planet warm while the sun was still faint. Without this atmosphere, Earth might have frozen early in its story. The sky may have glowed orange-red or yellow-brown due to volcanic dust and lingering gases. But even under that hazy sky, the surface was now far more peaceful than during the era of bombardment. This was the first time Earth wore a blue cloak of oceans. From a world of burning red, it had become a cool planet, where deep blue waters mingled with gray, rocky shores, forming the foundational look of a world filled with possibility. The vast sheets of water acted as a calming layer, smoothing out temperatures across the globe and creating a stable environment for chemical reactions to unfold. The story at this moment feels like the planet's recovery after a long fever. After ages of melting, cracking, and being pummeled by falling stone, Earth could finally rest. The million-year rains were like cool water soothing its rough, fractured skin. The oceans were like a soft blanket wrapped around a body healing from trauma. And in that peace, Earth was not just cooling, it was preparing to become a home. Even though its atmosphere was still thick with CO2 and methane, even though the skies were murky and the continents tiny and unstable, Earth was no longer the chaotic world it once was. These new conditions were opening the path for future life. Gentler temperatures, abundant liquid water, a wealth of organic molecules, and a geochemical environment rich in energy. And so, as blue spread across the planet's surface, Earth was ready to enter another chapter, one in which, from rock, from water, from light and shadow, the first living forms would take root. From those deep, dark oceans, something extraordinary was about to emerge, marking the shift from a young, turbulent world into the cradle of every life form that would one day follow. When the last of the endless rains finally slipped into the primordial ocean, when steam no longer covered the entire sky, Earth slowly revealed its new face, a deep blue world wrapped in the quiet that had just begun to form after hundreds of millions of years of upheaval. The surface had cooled and steadied, the crust thickened, the oceans spread wide, and the atmosphere, though still dense, felt less suffocating than before. All of these changes worked together like soft, hidden steps, preparing the planet for a future in which life might one day emerge. But even with liquid water and a calmer surface, one fundamental requirement remained, something Earth had to satisfy if it was ever going to sustain life. It had to sit in the right place in the universe, and remarkably, it did. From the vastness of space, Earth travels around the Sun on a path so well-tuned, it feels almost deliberate. Not too close, where the oceans would boil away into a suffocating haze, and not too far, where every sea would freeze into permanent, silent ice. Earth lies right within what astronomers call the habitable zone, the region where liquid water can exist, the most basic requirement for life. Had the planet drifted a little nearer to the Sun, the oceans would have evaporated, their vapors lost to space, leaving behind a world scorched and unforgiving, much like Venus today. A bit farther out, and the oceans might have locked beneath crushing layers of ice, a fate that resembles the frozen silence of Mars. But Earth avoided both extremes. It settled into a position so precise it feels almost miraculous, as if in the vastness of the cosmos, it somehow found a bed that was just right, like Goldilocks finding the softest, warmest place to sleep. The distance between Earth and the Sun is a strange gift of gravity and the distribution of matter in our planetary system. Because of that golden distance, the sunlight is not too faint and not too intense, keeping temperatures warm enough, steady enough, gentle enough for liquid water to persist for billions of years. Yet distance is only part of the story. What makes Earth even more extraordinary is the shape of the path it follows. While many planets move along slightly stretched, oval orbits, experiencing strong swings in temperature as they drift nearer or farther from their star, Earth's orbit is almost perfectly circular. That means the amount of sunlight it receives remains nearly constant throughout the year, helping maintain a stable global temperature and avoiding brutal seasonal extremes. The seasons we know today come mostly from the planet's axial tilt, not from distance changes. If Earth's orbit were more elongated, the planet would endure suffocating heat when it moved closer to the Sun, then bitter cold as it drifted away. Life, if it could even arise, would struggle to survive such dramatic shifts. But thanks to its round orbit, Earth enjoys the gentle, rhythmic climate needed for early chemical reactions in the ocean to unfold, steady, undisturbed, and unbroken by temperature shocks. This elegant orbit did not arise by chance alone. The arrangement of planets in the solar system plays a crucial role, especially the two giants, Jupiter and Saturn. With their immense gravitational pull, they act like invisible pillars that keep the whole system stable. Without them, Earth's orbit could easily have been tugged off course by passing objects, sending the planet drifting into scorching heat or icy darkness within just a few million years. Simulations show that planetary systems without well-placed gas giants often grow chaotic. Rocky planets collide, veer wildly off orbit, or experience climate swings too extreme for life to persist. In Earth's case, Jupiter is particularly important. The giant planet pulls in or flings away many dangerous objects and helps stabilize the orbits of the inner worlds. Thanks to Jupiter, Earth remains anchored in the habitable zone. In many ways, Earth's position is not just luck. It is the result of a delicate balance among countless gravitational forces, and the large planets are not the only guardians of stability. Earth also benefits from its precisely tilted axis. Though this part of the story belongs more deeply to the Moon and will be told in detail in later chapters, the truth is that Earth's 23.5-degree tilt creates the soft, varied seasons that help life flourish. Together with the nearly circular orbit, This tilt ensures Earth's climate moves in a steady rhythm, not too harsh, not too erratic, but just gentle enough for life to adapt and evolve. The harmony of Earth's orbit gives the planet a kind of quiet soul. If we imagine Earth as a growing child, its place in the sun's warm embrace is like being laid in a cradle at exactly the right spot. Warm enough, safe enough, and perfectly suited for growth. Everything life would one day need, light, warmth, liquid water, was within easy reach. As the oceans spread and the skies calmed, Earth began to feel truly serene. Liquid water no longer evaporated in great waves, the surface no longer burned relentlessly, and the atmosphere held enough warmth to keep the planet from freezing. Slowly, gently, Earth shifted from a world of storms into a world of balance, where every condition worked quietly together to cradle the first stirrings of life. And so, within the gentleness of its orbit, within the perfection of its distance, and within the stability granted by the giant planets, Earth entered its most important stage of preparation, the moment when, from rock, from water, from light itself, the first living forms would begin to appear. What comes next is the story of the anchor that keeps Earth's axis steady, the irreplaceable role of our companion, the Moon, in maintaining the delicate rhythm of the blue planet. After Earth found its golden position in space, holding a gentle distance from the Sun and maintaining a nearly circular orbit for billions of years, it seemed the planet had gathered all the external conditions it needed to support life in the future. The surface had relaxed, the oceans had spread wide, the atmosphere held enough warmth, and sunlight from the central star fell evenly across the surface. Not too hot, not too cold. Yet even when everything appeared ready, one essential factor remained, one that would determine Earth's long-term balance: the tilt of its own axis. And the next chapter of the story begins here, with the quiet companion that has circled Earth since the dawn of time, the guardian that keeps the planet steady against the invisible instabilities of the cosmos. Like all planets, Earth spins on an imaginary line that passes through its poles. This axis is not upright, but tilted about 23.5 degrees relative to the plane of its orbit. That tilt gives rise to the seasons: spring, summer, fall, winter, and brings rhythm to cycles of light and darkness. But the miracle isn't that the axis tilts. It's that the tilt remains so steady, nearly unchanged over billions of years. While many planets experience dramatic swings in their axial tilt, sometimes shifting by dozens of degrees, Earth holds its angle almost as if someone were gently keeping it in place with an invisible thread. That invisible thread is the Moon. From the moment it formed after the colossal collision with Theia, the Moon gradually drifted outward, but stayed close enough for its gravity to hold Earth's axis firm. The mechanism works like a giant anchor keeping a ship from capsizing in heavy waves. Earth spins, the Moon orbits around it, and between them lies a resilient gravitational bond. Through this connection, Earth's axis is not easily toppled or tilted wildly by the gravitational nudges of giant neighbors such as Jupiter or Saturn. To understand how crucial this stability is, we only have to look at Mars. The red planet once had flowing water, a thicker atmosphere, and likely a far more hospitable environment. But Mars lacks a large moon. Its tiny companions, Phobos and Deimos, are far too small to provide meaningful stabilizing force. As a result, Mars's axial tilt swings violently over time, sometimes reaching up to 60 degrees. These extreme shifts drive relentless climate upheavals, scorching heat followed by deep freezes, and may even have contributed to Mars losing much of its atmosphere to space. Earth, by contrast, escaped such chaos. Its gentle, persistent tilt has remained as steady as a long, unbroken breath. Thanks to that stability, Earth has 4 soft, predictable seasons that move through a familiar, comforting cycle. Spring brings back gentle light after colder months. Summer warms the world and fuels growth. Autumn shifts the leaves as life prepares to rest. Winter cools parts of the planet, creating the necessary balance for ecological cycles. These seasons shift by just the right amount, not too drastic, not too erratic. If Earth's tilt had wobbled wildly, the seasons would have become violent and unpredictable, making it hard for life to adapt. Many organisms might have disappeared before they had a chance to evolve. For billions of years, the Moon has carried out a subtle but essential role, keeping Earth's cradle swaying smoothly. If we imagine Earth as a living being dozing within the dreamscape of the cosmos, then the Moon is the patient caretaker holding the cradle steady, preventing it from tipping under invisible gravitational winds. This stability created the perfect climate for chemical reactions in the oceans to proceed consistently, for early organisms to form, and for evolution to unfold at its own pace. In the planet's early nights, when the atmosphere was still dense and the surface glowed with leftover heat, moonlight may have been blurred behind layers of thick haze. But as the skies gradually cleared, the Moon's reflection on the primordial ocean would have stretched into long, gentle ribbons of light, gliding softly across each wave. The tides, pulled by the Moon, ensured the seas were never completely still. These movements, small but persistent, helped stir the ocean's contents, giving organic molecules a chance to collide, bond, and advance along the path toward life. Not only the oceans, but the entire climate system benefited from the stable tilt. Global temperatures stayed within a comfortable range. Equatorial regions received steady sunlight without wild swings, while the poles followed their characteristic patterns of light and darkness, yet remained within limits that life could adapt to. Life could spread outward, from deep waters to land, from warm zones to cold, opening countless evolutionary pathways. Had the Moon not existed, Earth might have undergone climate upheavals powerful enough to erase life many times over. Primitive organisms could have vanished before they ever had the chance to develop further. But thanks to the companion born from a fated impact, this planet was granted a stabilizing tether, a gravitational anchor that kept it balanced amid the solar system's complex forces. And so, under the Moon's gentle glow, Earth has kept its steady rhythm for billions of years. That stability is not merely a scientific trait, it is a rare gift of the cosmos. With the Moon anchoring its tilt, the blue planet maintained the sway of its cradle, ready for the next chapter. One where even larger gravitational forces, especially the giant Jupiter, would continue guarding Earth from countless dangers drifting through space. After the Moon had kept Earth's rotation axis steady for billions of years, shielding the planet from harsh, chaotic swings and gifting it with a gentle rhythm of seasons, the story of the universe's protection over our world still didn't end there. As Earth continued turning in the balance granted by its quiet companion, another force, larger, farther, yet just as essential, was watching over from the outer darkness. This guardian did not come from a small satellite circling nearby, but from a giant standing far away, in a realm where sunlight fades but gravity remains strong enough to bend the destinies of wandering worlds. And so the story brings us to Jupiter, the silent elder of the solar system family. If the solar system were a vast family living in the expanse of space, Jupiter would be the eldest sibling, more than 300 times the size of Earth, massive enough that its gravity can catch or redirect anything rushing toward the inner worlds. Jupiter stands in a perfect spot, just beyond the asteroid belt, like a soft but powerful wall between the younger, fragile siblings and the endless storm of rocks drifting in from the cold outer regions. It's no coincidence that many scientists describe Jupiter as the gatekeeper of the solar system, one who speaks no words and makes no gestures, but quietly shapes the fates of countless comets and asteroids with its immense pull. When a comet or an asteroid plunges inward from the distant, frozen outskirts of the solar system, the first thing it often encounters is not Earth, nor Mars, nor Venus, but Jupiter's overwhelming gravity. Many small bodies have had their paths bent aside, drawn into new orbits, or captured entirely by Jupiter. Others have been flung away at such speed that they are ejected from the solar system forever, never to approach Earth again. All of these silent interactions, almost invisible to our eyes, have greatly reduced the number of objects that might have barreled into the region where Earth was still slowly nurturing the first stirrings of life. There have even been moments when Jupiter took a dangerous blow on Earth's behalf. One famous example occurred in 1994, when comet Shoemaker Levy 9 was torn apart by Jupiter's gravity. The fragments fell one by one into Jupiter's atmosphere, leaving enormous dark scars, temporary bruises on the planet's swirling cloud tops. Some of those scars were larger than Earth itself. Had that comet continued inward instead of plunging into Jupiter, the outcome could have been unimaginably different. Our small world could not have withstood such an impact without suffering devastating consequences. And so, when we look at Jupiter from afar, we see not only the largest planet in the solar system, but also a gravitational shield, a place where countless dangerous objects have been intercepted or deflected long before reaching the small rocky planets inside. Jupiter's pull didn't just protect Earth in its earliest ages, it has continued to safeguard our world for billions of years, even as life spread across the oceans and evolved into more complex forms. Yet not every threat was stopped. Earth's history still records catastrophic impacts, such as the Chicxulub asteroid 65 million years ago, the event that wiped out nearly all dinosaurs and many other forms of life. Though Jupiter caught most of the dangerous wanderers, some still slipped through the gravitational gaps and found their way to Earth. Even so, without Jupiter, the number of major collisions would likely have been far higher, so high that complex life might never have had the stability it needed to flourish. Many simulations suggest that if Jupiter were not in its current position, or did not possess its present size, Earth might have been bombarded so frequently that evolution could never have advanced far enough for humans to appear. Jupiter's protection goes beyond swallowing or ejecting intruders. Its gravity helps maintain order across the entire solar system. It keeps the asteroid belt at a safe distance, preventing its rocky bodies from constantly colliding and spilling inward toward the terrestrial planets. Jupiter also helps regulate more distant orbits, creating a grand architecture in which the planets move in steady rhythms instead of drifting chaotically. If the solar system were a giant clock, Jupiter would be one of the great gears ensuring everything turns at the right pace. And this stability, combined with Jupiter's role as guardian, granted Earth the long, peaceful window it needed for life to bloom, evolve, and diversify into the countless forms we see today. In this vast cosmic picture, Earth appears like a child sleeping safely in the universe's cradle. On one side, the moon gently steadies its rotation. Far beyond, Jupiter stands like a silent elder, catching much of the danger arriving from the dark. Thanks to these two forces, one soft and close, the other mighty and distant, Earth found the rare safety needed to become a home for life. And as the story continues, Our blue planet moves into a chapter shaped not only by stable orbits and an unwavering tilt, but also by the stirring of its own inner workings. The drifting continents, the flowing magma, the quiet movements that craft Earth's living skeleton. From Jupiter's outer protection, the tale now drifts inward toward the planet's own heartbeat, where plate tectonics begin shaping continents, oceans, and the future of life itself. When we reflect on Earth's long journey, it becomes easy to feel that the blue planet has always been protected from many directions. From the distant reaches of space, Jupiter has quietly acted as a gatekeeper, stopping countless dangers before they could drift toward the inner worlds. But Earth's protection did not come only from the outside. Deep within the planet itself, another silent force has been working without pause, steadier and more persistent than any shield we could imagine. If Jupiter is the elder sibling watching from afar, then beneath layers of rock and stone, Earth has forged its own armor to keep every growing form of life safe on its surface. That armor is the magnetic field, a precious gift born from the planet's molten heart. To understand why Earth's magnetic field is so important, we have to return to the early days, when the planet had cooled after its fiery youth. As the surface solidified into a rocky crust, the deep interior still held enormous heat, left over from the planet's violent beginnings. Earth's core, therefore, became a place where iron and nickel remained molten, swirling endlessly under immense pressure. A solid inner core, a liquid outer core, a hot mantle, a cool crust. Together they formed a layered structure like a beating heart working to its own quiet rhythm. As Earth spun, the molten metal of the outer core churned in complex currents, creating an effect called the geodynamo. This is what generates Earth's magnetic field, a cloak of invisible, resilient strength that wraps around the entire planet. Seen from space, that field resembles a magnetic bubble stretched toward the sun and trailing off behind the planet, enveloping both atmosphere and ground. Though invisible to the human eye, Earth's magnetosphere is one of the most essential ingredients that separates our living world from so many barren, lifeless planets. Thanks to this magnetic shield, the atmosphere, light and fragile, easily stripped away, is preserved across billions of years, providing stable conditions for liquid water to exist. The field also shields Earth's surface from the relentless assault of high-energy particles blown outward by the sun in constant solar wind. Those solar winds, if left unchecked, could destroy everything from oxygen molecules to delicate organic compounds. They could thin the atmosphere, leave the surface freezing or scorching, and push the planet into an irreversible spiral of decay. Mars is the clearest reminder of what such a fate looks like. Today, the red planet is known as a barren world, with an atmosphere so thin it cannot hold liquid water and a surface bombarded by harsh radiation. Yet geological evidence shows that Mars once had rivers and lakes. When its core cooled and stopped generating a magnetic field, the solar wind began stripping away its atmosphere, and life, if it ever emerged, lost its chance to continue. Earth's story is different. Its invisible armor has worked faithfully for more than 4 billion years. Because of it, the air remains thick enough, the oceans remain blue, and the surface remains capable of sheltering countless living things. If Earth were a child resting in the cradle of the cosmos, then the magnetic field would be the warm blanket wrapped around it, keeping heat in, keeping danger out. This image helps us picture the magnetic field as a soft yet unbreakable shield, embracing Earth with both gentleness and strength. When high-energy particles from the solar wind collide with the field, they are pushed aside, gliding along the outer boundary of the invisible shield. Only a tiny portion can slip through near the poles, where the magnetic field opens like two natural funnels. There, those particles interact with the atmosphere, sparking atoms to glow and creating the auroras. The auroras are not only enchanting displays of color, they are living proof that Earth's magnetic armor is doing exactly what it was meant to do. Their greens, purples, and soft reds shimmer like gentle nightlights lit at the planet's two ends, signaling that the solar wind has reached Earth, yet showing that the planet remains safe in the magnetic embrace. If we were to personify these forces, we might imagine Earth as a quiet knight, clad in armor forged from its own molten heart. This knight does not boast or display its strength. It simply stands guard, protecting the small, fragile lives that rely on its surface from the unseen dangers of a vast universe. The solar winds rush in like arrows, but each one is turned aside, stopped by the heavy shield before it can reach the ones it might harm. What's fascinating is that this armor is not rigid. Earth's magnetic field changes over time, sometimes growing stronger, sometimes weaker, sometimes even reversing its poles after hundreds of thousands or millions of years. But even during these reversals, when north becomes south and south becomes north, the field does not disappear. It still wraps around the planet, still performs its protective role. This stability, lasting across billions of years, is one of the most crucial foundations for life's enduring presence. After understanding this invisible armor, one can more deeply appreciate that Earth is not only protected from afar by Jupiter, it also protects itself from within. Layers of shielding pile gently atop one another: a stable orbit, a loyal moon, a steadfast magnetic field. Together, they form a system of support more intricate than any machine humanity has ever designed. And as the story moves onward, the blue planet continues to reveal more of its inner liveliness: the slow motions of drifting plates, the rise of volcanoes, the oceans that expand and retreat. From the magnetic shield, the narrative now drifts softly into Earth's internal breath, where plate tectonics begin shaping climate, forming continents, and maintaining the environment that life needs to continue its long and delicate journey of evolution. Across Earth's long journey, the magnetic field has been the quiet armor shielding life from the sun's fierce and restless winds. But life's protection comes from more than the invisible forces drifting around our planet. Earth also sustains itself in a deeper, steadier way, almost like a living body that knows how to regulate its own heartbeat. While the magnetic field keeps danger at bay from the outside, within Earth's interior, a slow yet powerful rhythm has been pulsing without pause: the breath of plate tectonics. This silent breathing has shaped continents, opened oceans, raised mountain ranges, and most importantly, kept Earth's climate stable for billions of years. After understanding how the magnetic shield has protected the planet, the listener can gently shift to a new image of Earth. Not just a knight clad in protective armor, but a living being subtly moving in its long geological sleep. Unlike the moon, whose surface has stayed nearly unchanged for billions of years, or Mars, a world that once stirred and then fell abruptly silent, Earth is constantly turning beneath its seemingly quiet crust. That crust is not a single unbroken shell, but a mosaic of great plates, like wooden boards floating on a warm, soft sea of mantle beneath them. This phenomenon is called plate tectonics, a process that makes the planet seem as though it is breathing through long, slow cycles. At times, plates pull apart, opening new oceans. At times, they collide, pushing rock upward to build towering mountains. Sometimes a plate sinks beneath another, carrying rock and carbon deep into Earth's interior. Together, these motions form a vast cycle, so slow that a human lifetime cannot sense it, yet so powerful that it has sculpted the entire face of the planet. This planetary breathing shapes more than just the land. It also moderates climate in ways many would never imagine. Earth runs a natural carbon cycle, powered largely by plate tectonics. When volcanoes erupt, they release CO2 into the atmosphere, warming the planet. When rain falls onto newly formed mountains, water dissolves CO2 and carries it to the oceans, where it binds with minerals to form limestone. And in the deep trenches where plates sink, carbon-rich rocks are drawn back into Earth. After millions of years, that carbon is reborn in new volcanic eruptions. The whole cycle acts like a breath. Volcanic outgassing is the inhale, weathering and carbon transport is the exhale. This rhythm keeps atmospheric CO2 at a stable level, not too high, or Earth would swelter and dry out like Venus, and not too low, or it would freeze like the distant icy worlds. Even as the sun grows brighter over time, Earth maintains temperatures suitable for life because of this natural, slow-moving climate regulator. What's extraordinary is that among the rocky planets of the solar system, only Earth has such vigorous motion. Venus, though similar in size, has a crust that does not break into plates. Heat inside cannot escape evenly, and the surface is smothered in a thick, toxic atmosphere hotter than molten metal. Mars once had geological activity, but cooled quickly because of its small size, leaving its crust frozen and unmoving. Only Earth has kept this long, steady breath, a self-regulating ability that preserves climate fit for life. Imagining Earth as a breathing organism makes the story feel soft and intimate. The listener can picture far beneath their feet, deeper than any drill could ever reach, slow currents of hot material gliding and shifting, creating a rhythm all their own. That rhythm lasts for millions of years, long enough for life to climb from simple ocean cells to creatures that swim, crawl, and fly, and eventually to beings who look to the sky and wonder where it all began. Each time two plates slide past each other, sometimes sending out vibrations that humans call earthquakes, it is only a small part of the planet's greater breath. When plates pull apart and magma rises to form new rock, that is Earth's warmth exhaling from its deep interior. When one plate sinks beneath another, it is a breath pulling carbon back into the place where the cycle began. What people often see as violent or frightening is, in truth, the planet's natural biology, a rhythm that has kept its climate balanced for billions of years. If Earth were a child resting in the cradle of the universe, then plate tectonics would be its gentle chest, rising and falling in a long, peaceful sleep. These slow breaths give the planet not only vitality, but also a remarkable gift of self-regulation. Because of them, despite dramatic changes in the sun's energy, life has not been scorched to dryness nor frozen into extinction. In this light, Earth appears both powerful and tender. Powerful enough to lift mountains from the ocean floor, yet tender enough to cradle fragile life within a stable climate. And as the planet continues its steady breathing, the story takes another quiet step toward the most miraculous moment in Earth's history. The time when the first seeds of life awakened in the ancient waters, opening a new chapter in the cosmic journey that humanity would one day inherit after billions of years of waiting. As the planet's long, slow breathing continued to echo through the darkness of ancient time, Earth gradually settled after billions of years of restless transformation. The tectonic plates still drifted quietly, shaping mountains and oceans like a gentle symphony stretched across the ages. Thanks to that quiet breath, the planet's climate found a steady rhythm, creating a rare moment of calm in cosmic history. A time when the oceans were no longer boiled away, no longer frozen into despair, but maintained a warm, comforting balance, just right to become a cradle. And in that calm, when every condition finally aligned, a miracle unfolded. The moment Earth shifted from being a world of only rock and water into a world that carried something more. Life. Life did not erupt with a roar or blaze into existence in a brilliant flash. It arrived softly, like a tiny seed cracking open beneath warm soil. Around 3.8 to 4 billion years ago, in the planet's warm oceans, where organic molecules were stirred by tides shaped by the moon and kept stable by the slow breathing of plate tectonics, the first primitive cells emerged. They may have been simple anaerobic bacteria, needing no oxygen, only a quiet environment and a bit of chemical energy to survive. They did not know they were the first step in a journey that would reshape the entire face of the planet billions of years later. If Earth had once been a mischievous child during the era of meteor bombardment, and then a fierce young adult during the age of violent tectonics, it now stepped into a new role, a gentle mother. The atmosphere, oceans, and land joined together like the three parts of a vast cradle, holding the first tiny organisms. Earth did not simply allow them to exist, it nurtured them. Organic molecules drifting through the sea were gathered by the tides, warmed by geothermal heat, shielded by the magnetic field, and regulated by the carbon cycle. It was a sequence of events so improbably perfect that it felt as though the universe had quietly chosen Earth to be the cradle of life. Over time, these single-celled organisms began to diversify. Some evolved the ability to photosynthesize, releasing oxygen into the oceans and eventually into the atmosphere. This was a turning point of astonishing importance. A world once filled with toxic gases slowly transformed into one rich with oxygen, turning the atmosphere into a soft blanket for future breathing life. This event, known as the Great Oxygenation, about 2.4 billion years ago, opened entirely new evolutionary pathways. Algae, cyanobacteria, and countless other life forms flourished, building the first webs of the planet's ecosystem. Oxygen did more than cleanse the air. It allowed organisms to harvest energy far more efficiently through respiration. Because of that, life was no longer limited to the single-celled. Around 600 million years ago, multicellular organisms appeared, soft-bodied, simple, but diverse, filling the oceans with new shapes and possibilities. Their arrival marked the beginning of a new chapter, where complexity began to accelerate. Then came a wondrous burst of life, the Cambrian explosion. During this time, the oceans awakened. Creatures with bones, with eyes, with mouths began to dominate the seas. Fish swam through deep blue waters, corals built reefs, and animals with shells, spines, and tentacles appeared in dazzling variety. The land was still barren, but the oceans had become a vibrant stage for evolutionary drama. Not long after that, on the universe's timescale, plants rose from the soil and spread their green across the continents. As vegetation covered the land, it released even more oxygen, making the atmosphere increasingly stable and breathable. Animals followed, crawling onto shores, entering forests, sprinting across plains. The entire planet bloomed into a canvas painted with life. Earth watched it all in silent patience. The first fish wriggling through coastal mud, the massive forests of the Carboniferous, the majestic dinosaurs that ruled the land for millions of years. Then a great asteroid swept across the sky, ending the age of the giant reptiles. From their ashes, small mammals grew and flourished, branching into countless forms. And finally, very late in the story, humans appeared, only in the last 2 million years, a brief but profound whisper in the symphony that had been playing for billions. Looking at this entire journey, it is hard not to feel a deep emotional resonance. Earth, once a wild child of the cosmos, became a gentle mother whose warmth nurtured every fragile beginning. Every creature, from tiny bacteria in the ocean's shadowed depths to humans standing beneath the night sky, is one of this planet's children. No matter how many upheavals Earth faced, bombardments, meltings, ice ages, extinctions, it continued to cradle life and help it grow. And here, in the peaceful quiet of a planet that spent billions of years preparing for the story of life, the tale begins to drift toward its closing moments. For after this great blossoming, there remains one final chapter, soft, calm, and low, where the blue planet whispers its last lullaby to those listening to the long story of the universe. After witnessing the first moment when life sprouted in the primordial ocean, and following the billions-year journey of evolution that unfolded afterward, the listener has, in a sense, traveled through an entire miraculous lifetime of the blue planet. Simple cells became green forests, shimmering seas, and skies filled with breath. Tiny organisms grew into giants, and giants gave way to new forms of life. Through every era, Earth was both the stage and the patient mother watching over each transformation. And when the story reaches the present, when humans appear like a late whisper, quiet but self-aware, it signals that the tale is gently making its way toward a closing lullaby from the very planet that has nurtured everything. Looking back at the full story, the early chapters were filled with chaos. Drifting stardust, fiery collisions, boiling magma oceans, erupting volcanoes, relentless meteor storms. Yet all of those seemingly destructive forces became the foundations that allowed Earth to become a complete home. From molten heat came the formation of an iron core. From a colossal impact came the moon, steadying Earth's rotation. From violent showers of meteorites came water and organic molecules, the first ingredients of life. And from the slow shifting of tectonic plates, the climate found the balance needed to keep the planet warm long enough for life to flourish. These upheavals were not disconnected events, but a continuous chain, each one like a breath of the planet itself. Every breath, whether loud or quiet, carried Earth into a new equilibrium. Seen in this way, Earth was shaped not only by matter, but by persistence. The disasters we often imagine, collisions, ice ages, mass extinctions, were in truth crucial transitions, helping ecosystems renew with even greater vigor. In hardship, there was opportunity. In destruction, there was renewal. And in chaos, a quiet order waited to be born. Understanding this, the listener can feel the deeper meaning of the journey. The entire history of the universe had been quietly moving toward the moment when life would not only exist, but become self-aware. Humans, though startlingly late in the immense timeline, are the clearest evidence of Earth's endurance. Every atom in the human body was once stardust, once drifting through the protoplanetary cloud, once heated in magma seas, once swirling in the primordial ocean, once absorbed into the carbon cycle, before becoming part of a mind capable of looking back across time to understand its own origin. And at the end of this billions-year story, one can imagine Earth holding its children in its wide, ancient arms. No words are needed, just that quiet feeling, soft as night mist, reminding us that this planet has endured everything and continues to shelter life every day. Now, after the long journey, Mother Earth is holding us in her warm embrace. Out there, the universe remains vast. Comets still roar across distant skies. Supernovae still send shockwaves through the void. But here, on this planet, in the stillness of tonight, everything is peaceful. This lullaby drifts gently through the air, soothing each listener, wrapping them in the deep safety that Earth has taken billions of years to build. For every person, no matter where they are, carries the same origin: ancient stardust. When we look at the night sky, we are not just seeing distant points of light. We are seeing a reflection of ourselves from billions of years ago. It is a quiet yet unbreakable connection, reminding each listener that they belong to this planet in the most profound way. Not in an abstract sense, but in the scientific truth that the human body is made from the material of the cosmos. As the story slowly closes, one last image forms, gentle as the final breath of a lullaby. The moon hanging softly outside the window, not too bright, just enough to blur the line of the horizon. The sound of waves, if they could enter this moment, would whisper against the shore. Not loud, only a tender murmur of water to land. These lights and sounds blend into a lullaby that has been singing since Earth first formed its thin, fragile crust. And so the story ends with a quiet invitation. Close your eyes and feel your own breath as an echo of the planet's breath. Earth is still alive, still moving, still warming every small creature it carries. Listen to the breath of Earth. Your planet is singing you into a peaceful dream. From within that silence, the listener carries an enveloping warmth, a sense of protection, and a gentle gratitude for the green and living home beneath their feet.